Congratulations on making it to the end of section 3 of the Complete Android Developer course. You've covered a lot of stuff already in the course, as well as making your currency converter app in the previous section. In this section, we've looked in Java in a lot more detail, and we've covered variables, arrays, lists, maps, loops. We've created random numbers, as well as our little higher or lower app. And then we've looked at classes as well, and also if statements. So we're going to try and put as much of this together in this little app. And I've called this app Number Shapes. There are two types of numbers that generally have shapes, and they are triangular numbers and square numbers. And what we're going to do is create an app which allows the user to put in a number, and it will tell them whether it's a triangular number, a square number, both, or neither. Now, this may not be the most useful app in the world, but it will allow us to practice almost everything that we've covered. And also does require you to do a little bit of searching online as well to find a couple of new techniques that we haven't looked at yet. You may even need to look up what a square number is if it's been a while since you've worked with them. So that's it. If you're not really sure where to get started, then just follow along with my explanation. But otherwise, give it a go, best of luck, and remember to try and do it in an object-oriented way with classes if you possibly can. Best of luck. Alright, I hope you managed it. You may notice that I've actually settled in the browser rather than going over to Android Studio, and that's because I'm actually going to create the logic for the app in the browser and then move it over into Android Studio. And that's slightly more straightforward for me here because I can then run the logic several times without having to compile the app every time. So let's start afresh with a new Hello World program, get rid of that one line that we don't want, and then save as Number Shapes. So remember, our main aim here is to work out whether a particular number is a triangular number, a square number, neither, or both. So let's start off with a number class. You may notice now that I gave you a bit of a clue as to how we might set this out in the final example of the previous video. So here's our number class, which is going to have our number variable contained within it, and then our tests for is it a square number, is it a triangular number. So let's start by creating our variable number, and then I'll work first on whether it's a triangular number. So let's create a public method that returns a Boolean, and we'll call it is triangular. There we go. Now let's just remind ourselves what is a triangular number. There we go. So it's the sequence 1, 3, 6, 10. So the difference goes up by 1 every time. So the way I'm going to test for a triangular number, and you can of course do this many different ways, is I'm going to have a counter variable x, so int x, which is initially 1, and just like we had when we displayed the first 10 triangular numbers a few videos ago, I'm going to have a triangular number integer as well, which will work my way up through the triangular numbers. And essentially what I'm going to do is keep generating triangular numbers until we get to the number. And either the number will be equal to a triangular number or it won't. If it is, then it is a triangular number. If it's not, then it's not. So we want to keep going as long as, so while our triangular number is less than our number that we're working with. And essentially we want to keep going up the triangular numbers as long as this is the case. So, how do we build triangular numbers? Well, what we did before was increment our counter variable, so x is now 2, and then take our triangular number and add x to it. So this will create a series of triangular numbers, and it will keep on going until either triangular number is greater than the number or triangular number is equal to our number. So once we're there, we can check to see if triangular number is equal to number. That means our number must be a triangular number because it's in the sequence of triangular numbers. So if that's the case, then we're going to return true. Whoops. If it's not, we're going to return false. And that's it. That's our method for testing whether our number is triangular or not. So, of course, we should definitely test that. So let's create our new number. I'll call it my number, which is a new number. Hopefully you're writing out this object-oriented code quite smoothly now, which is a big step forward because it's by no means easy to get to grips with. And then we'll set my number.number. Initially, let's set it to a triangular number. So say 6, for example. And then, because we're just testing, I'm going to just output the result to the logs, to the console, sorry. So my number dot is triangular, and then brackets, and with any luck then that will return true because 6 is indeed triangular. Let's take a look. Okay, looking good. Let's try it on a non-triangular number. False. Brilliant. Okay, just a couple more. 10 is triangular, so that's true. 20 isn't. False. Fabulous. Okay, so we've got our is triangular test up and running. Now we need to create an is square test. So I'm going to do that up here. So same as before, public, and we're returning a Boolean, and we'll call it is square. So already, hopefully you can see the sensibleness of keeping all this logic in one place. It just makes a lot of sense, and then when we're working down here, we don't really need to refer to the logic much at all. So a square number, let's just have a quick Google, is a square number. So a square number is the product of a number multiplied by itself. So 1 is a square number because it's 1 times 1. 4 is a square number because it's 2 times 2. 9 is a square number because it's 3 times 3, etc. So probably the best way to test whether a number is a square number or not is to find the square root of that number and see if it's a whole number. So the square root of 4 is 2, for example, because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9, etc. So how do we find the square root of a number? Well, that's one thing we haven't covered yet. So I would expect you to search for something like Java. Oh, you can see I've already done it just to check that it's there. Java, there's a square root method. Perfect. That's exactly what we want. So it looks like the method that we want is math.squareroot x. So I'm just going to copy that and jump back over. Now, just to check that this works, I'm going to do a quick test. So let's do the square root of my number dot number. There we go. Let's take a look. So that should give us the square root of 20. Okay, fair enough. Perfectly reasonable request. I've said this is going to return a Boolean and it doesn't. So let's just for now return true so that we can run our code. There we go. That looks like the square root of 20 to me. Brilliant. So that is exactly the function or method that we need. So let's copy it again up here. So let's create a double. I'll call it the square root, like that. And that's going to be math.squareroot. And here I just want to square root number. All right, hope you're still with me. The main thing I want to test about this is whether or not it's a whole number. Because if it is, then we're dealing with a square number. If it's not, then we're not. That's another thing we haven't worked out how to do. So let's do a quick Google. Java test. Oh, again, you can see I've been there just to make sure that everything is available online. So how to test if a double is an integer. That's a perfect question for us. So yep, that's exactly what we want. Okay. So it looks like we use the math.floor method. So math.floor, if you don't want to read that, is a method that finds the integer below the number that we're looking at. So at the moment we've got, say, 4.47. So the integer below that is 4. So actually that makes a lot of sense. If the number that we're looking at is the same as the number when rounded down, then it must be an integer or a whole number. So that's what we want, I think. If we have a look at the other part, that tests whether it's infinite or not, which probably is not going to be relevant for us. So I'm just going to leave that bit out. But if you want to just copy that in, then it's not a major problem. Okay. So this is our test. So we want to test if, we don't want variable this time, we want square root is equal to math.floor of the square root then it is a square number, so return true. If that's not the case, return false. There we go. So just to recap, we've found the square root of our number, and then we've done a test to see whether that number is equal to that number when it's rounded down, which is just another way of saying, is that number a whole number, an integer? And if it is, then our original number must have been a square number. If not, then return false. Okay. So now let's use my number dot is square. And of course, we don't need anything in those parentheses anymore. So 20 is not a square number. So when we run this, it should give us false. Hurrah! Let's try a square number then. 9. 9 is a square number and it's giving us true. Fantastic. I think I'll just try a couple more. 50 is not a square number, so that's false. But 49 is a square number, and that's true. So that's pretty good. So now we've got a bunch of code that we can just copy straight into our app because it's so nicely set out. It doesn't involve any buttons or getting the value of text edit fields or anything like that. It's nice and clean as far as that's concerned, which means we can just use it straight away. And of course we could copy it into another app if we wanted to use this somewhere else as well. So that's one of the advantages of this nice clean class structure. So let's take this code and make our number shapes app. So over to Android Studio. And I'm going to start in the usual way, creating a new project. I'll call this one Number Shapes. and we'll go for all the usual options. And as usual, we'll start with creating the layout. Give ourselves a bit more room. Get rid of the text view and bring in our own. And then let's write our text. So I'll say enter a number below to find out if it is a triangular number, square number, or both. There we go, and it nicely goes on to 2 lines for us. And I think I'll just change that to centered. Great. And I'll add top and left and right constraints. Okay. Then our number text field. This one I'll stretch out a bit. And then add the constraints. Let's make them match. Excellent. And finally, our button, which will say test number. And again, we'll center that and add the constraints. I'll add an on-click method of test number, and then I'll run the app while we write a bit of code. So as per usual, let's create a method called test number, which is called by a view called view, which logs button pressed. There we go. And I'll rerun the app so I can test that. But I'll also copy in our number class. Without the actual code to make it run, because we'll add that ourselves in a minute. There we go. Okay, let's just have a quick look. Oh, definitely an issue with our layout there, but let's just quickly test the button, make sure that works. There we go. So the button works. What's gone wrong with the layout? Most likely I've forgotten to add some constraints. Ah, there we go. A top constraint is needed for the edit text. Lovely. Let's just check, make sure that that's now displaying correctly. Much better. There we go. All right. So this should now be fairly quick because we've already written the code which does the work of our app. Let's just remind ourselves how we use it. So I'll put the code into the test number method. So we create a new object called myNumber of the number class, which is a new number, and then we set the number equal to, in this case, 49, and then we check to see if it's a square number. So let's do that, but instead of using 49, we'll use the number that the user has entered. So we're pretty used to doing this now. We're going to find the edit text using find view by ID and then r.id.edit text. And then we want to convert the value of the edit text to a number, or to an integer, to be more precise. So we'll take edit text dot get text dot toString, and then we want to take the integer class and we want to pass integer from that string. So we're going to create an integer from the number that's been entered, and with any luck we'll find out whether it's a square number or not. Let's have a look. So let's take a square number first of all, 25. Test the number, true, that's looking promising. Now let's take a number which is not a square number, 26, false. Wonderful, looking great. Okay, so now we just need to give the user some feedback, and we'll do this in our usual way with the toast. And we'll start then by creating a message string. And we want to test to see if my number is square and my number is triangular. Then we want to set the message equal to, well, we want the number itself first of all, so that's the value of the edit text. To string, and in this case we want to say is square and triangular. Else, if my number is square, now we don't need to check for triangular, because if we're here we know that it's not both square and triangular because we used an else. So if we're here and it's square, then it must just be square. In fact, I've just thought of a bit of a shortcut. We can use message and then set that equal to the number originally, because we're always going to start with the number in our message rather than having that every time. And then there's a couple of ways that we could add that on. We could say message equals what message already is plus that, or there's a nifty way to do that, plus equals. So that will append is square and triangular to whatever is already in the message variable, in this case the value of the edit text, the user's number. There we go, so that will make everything a little bit neater and again easier to update and manage. So it's square but not triangular. Keep on going. If it's triangular, then the opposite's true. So it's triangular, but not square. And then finally, if we get to here, it's neither triangular nor square. Let's not forget the full stop there. All right, and let's update our code to do a toast instead of a log with the message. And again, I think we'll make this a long message. All right. Hope that all makes sense. As always, quite a lot to get the hang of there, so it might be worth just going back and re-listening to the last 3 or 4 minutes if you're not sure how we put all that together. But otherwise, let's check it out and see if it works. So let's find a square number first. 9. So 9 is square, but not triangular. That's right. Now let's find a triangular number. 10. Triangular but not square. Excellent. And then let's try a number which is both triangular and square. 36, for example. Hey, it's got that too. And then one that's neither. We'll try 7. Fantastic. Now we're just going to do one slight tweak here. You may have noticed with this app, and indeed with the higher or lower app that we made, if the user presses the test number button without entering anything into the app, our app crashes. Now obviously the user shouldn't do that, but it would be nice if we could offer them a friendly message rather than just the app crashing. So I'm going to suggest a way to do that here in our test number method. So what we want to do is check to see whether or not the edit text field is empty. And there's actually a really easy way to do that. So if we take our edit text, get the text in the usual way, and then we look for is empty, that will tell us whether the string has a value or not. So if it is, then let's set the message to be a certain thing. So what I'll do is I'll define message up here, and then we'll just update it where we need to. Please enter a number. And then if that's not the case, then we'll do everything else. There we go. So let's just quickly check that that works. So if I now test number, it says please enter a number. Fantastic. So that's just a basic bit of error checking. There's a lot more that we could do. For example, if the user tries to enter a negative number, that's going to cause us problems, or a decimal. But I'll leave that to you as a challenge. We will be dealing with similar and much more complicated errors than that later on in the course. But for now, once again, congratulations on getting to the end of this section. You've learned a huge amount about programming in general and Java specifically. And hopefully you'll be pleased to hear we'll be staying in Android Studio for pretty much the rest of the course, apps as we go along. And in the next section, we'll be focusing on media, particularly images, animations, and music. Go and have that congratulatory cup of tea, and I'll see you in the next section.